Hello students, today we are going to study matrices from class 12th. It is a very interesting topic used in further studies, so watch the video till the end to understand it properly. Suppose there are 5 students who want to purchase pencils and erasers. How can I note this data? I can have the rows for each of the 5 students and I can have columns for pencils and erasers representing the number they want. So basically if I want to do more calculations, I can represent it in that form. So let us define a matrix. A matrix is an ordered rectangular array of numbers or functions. The numbers or functions are called the elements or the entries of the matrix, and we generally denote the matrices by capital letters. Some examples are given over here. See, in the first example, you can see it has 3 rows and 2 columns. So matrix having m rows and n columns is called a matrix of order m cross n, or simply m cross n. For example, if a matrix has 18 elements, then what are the possible orders for it? It can be 1 cross 18, means 1 row 18 columns. 18 by 1, that means 18 rows 1 column. 6 cross 3 means 6 rows 3 columns. 3 cross 6, 3 rows 6 columns. 2 rows 9 columns, 9 rows 2 columns. These are the possible orders for that matrix having 18 elements. But suppose if a matrix has 5 elements, then there will be only 2 possible orders, 1 cross 5 and 5 cross 1. 1 row 5 columns, 5 rows 1 column. Why? Because 5 is a prime number. See, we can have different types of matrices based on how the elements are arranged. Suppose if a matrix has any finite m number of rows and only one column, means it is of the order m cross 1, then it is called a column matrix, only one column. Like for example, 5, 8, 2 given over here. Suppose it just has one row, that means it is 1 cross n, then it is called a row matrix. An m cross n matrix is a square matrix if m equal to n, means if same number of rows and columns, then it is called a square matrix. Otherwise, it is a rectangular matrix. Diagonal matrix means if a matrix is there in which aij is equal to 0, where I is not equal to j. That means suppose if I am having A11, A12, A31, A32, this is how the elements of the matrix are generally represented. So when the number of the row and column, means if I am having A12, 1 is not equal to 2, in that case the entry is 0. So that will be a diagonal matrix. In short, diagonal matrix means only the diagonal elements will be non-zero, other all elements will be 0. The example is given over here. Suppose if I am having a matrix AI which has elements of the form Aij and of order m cross n, it is a scalar matrix if Aij is equal to 0 when I is not equal to j. So over here again it is given that it is a scalar matrix when I is not equal to j, and Aij is equal to k for some constant k. That means a scalar matrix is a diagonal matrix in which the non-zero element is the same, like given over here. It is 4, 4, 4, the elements in the diagonal. That is a scalar matrix. A matrix A is an identity matrix or a unit matrix if Aij is equal to 1 when I is equal to j, otherwise it is 0. That means a unit matrix is obviously a diagonal matrix, but the elements of the diagonal are 1. A zero matrix means all the elements are 0. Two matrices are equal if first of all they should be of the same order, and secondly all the corresponding values in both the matrix are equal. Some matrix operations. They are simple algebraic operations which will be clear as we discuss the examples. If you multiply a scalar by a matrix, then each and every element of the matrix has to be multiplied by that scalar. That means if I multiply minus 1 by a, I get a matrix which I denote by minus a. What is a minus b? A plus the matrix b into minus 1. A plus b will be always equal to b plus a. It is commutative. A plus b plus c, and if the bracket is changed, obviously all should be of the same order, and if the bracket is changed, then it will give the same answer. That means it is associative. Any scalar k into a plus b is equal to k into a plus k into b. If you are having two matrices A and B, and if you multiply them, you get a matrix called C. Suppose C has elements of the form CIK. Now this is important, matrix multiplication. We will see also examples based on that. But first of all, if you want to multiply two matrices, that means first one, see here, it is m cross n. The second has to start with n. That means second has to be of the order n cross something. So the resultant matrix A into B will be of the order m cross p. This is how you get the multiplication of two matrices. Now to get these elements of C, what you do is, suppose I want the ikth element of matrix C. We take the ith row of the first matrix A and we take the kth column of the second matrix B. We multiply them element wise and then you take the sum of all these products. It will be very simple as we see an example based on that. Some results follow which we generally have A into B into C is AB into C. A into B plus C is AB plus AC. A plus B into C is AC plus BC. Next we define the transpose of a matrix. Very simple. If you have a matrix A, to get its transpose, which is generally denoted by A raised to T or A dash, you just have to interchange the rows and columns. That means if A has elements Aij and if it is of the order m cross n, then A transpose will have the elements of the kind Aji and the order will also reverse n cross m. It is given over here, the rows go to column and the column goes to rows. Correct? Some very important results. A transpose is A, K into A whole transpose is K into A transpose. K remains unaffected. A plus B whole transpose is A transpose plus B transpose. AB whole transpose is B transpose into A transpose. Remember that. Correct? For example, what does this mean? If I have a matrix A given over here, transpose means I have just interchange the rows and columns. Again, I take the transpose of that transposed matrix. Then I will get the original matrix A. So this shows A dash dash is A. Similarly, other results can also be proved. Next concept is symmetric and skew symmetric matrix. See, we will do examples based on all these things, but first we will see the concepts. A matrix A is called a symmetric matrix if A transpose is equal to A, and it is skew symmetric if A transpose is equal to minus A. See, suppose if I am having a matrix A, first the matrix given over here 1 1 minus 1 1 2 0 minus 1 0 5. Now we just try to interchange the rows and columns for this. You will be getting the same matrix, correct? 1 1 minus 1, first column will go to the row, which is again 1 1 minus 1 1 2 0. The second column will become the row, which is again 1 2 0. In short, A transpose and A will be same, so it will be called as a symmetric matrix. In the second example, if you see, it is a skew symmetric matrix because the elements of A transpose I am getting by just multiplying minus 1 by each and every element. First column 0 minus 1 2. If that becomes the first row and if I just multiply by minus 1, it will become 0. Minus 1 means 1 and minus 2. Correct? So in short, skew symmetric matrix means A transpose is equal to minus A. Inverse of a matrix. This is an important thing. You can find the inverse of any matrix. If A is any square matrix, first condition is it should be a square matrix of order m. And if there exists another square matrix B of the same order m, that means A has m rows m columns, B also has m rows m columns, such that A into B is B into A, which is equal to the identity matrix, then B is called the inverse of A and it is denoted by A raised to minus 1. In this case, you can say that the matrix A is invertible, otherwise it is not invertible. A rectangular matrix obviously does not have an inverse because first thing is it is not having the same rows and columns. It is not possible to find the inverse. If B is the inverse of A, then A is also the inverse of B. Now if you want to represent the different types of matrices in the general form, correct? then this is how it is given. First is unit matrix. Unit matrix means only the diagonal elements are 1, 1, 1, other all elements are 0. Diagonal matrix means you just have the diagonal elements non-zero. All other elements are 0. Square matrix means same rows, same number of columns. Now you can also have upper triangular and lower triangular matrices. Upper triangular matrix means all the elements below the diagonal are 0. That is called upper triangular matrix. And if all the elements above the diagonal are 0, then it is called the lower triangular matrix. Symmetric and antisymmetric matrix also you know, but if I want to represent in a general form, see, if I want a symmetric matrix, A transpose and A will be same. Means if you interchange rows and columns, it will not make any difference. You will get the same matrix. So what will happen is, in the first column, if I am having A11 BC, in the first row also I will have A11 BC. Similarly, in the second column, if B A22 D, then in the second row also B the A22 element and D. So this is how you in general represent a symmetric matrix. Same way, antisymmetric matrix, A is equal to minus of A transpose. So in this case also the elements are listed. You have the general matrix. If you have a matrix which is not square matrix, it is a rectangular matrix, then you can have the elements of the form A11, A12, A13, so on, and same way A21, A22, A23, so on. There are some important theorems or results which we need to prove for matrices. In that, the first theorem is, for any square matrix A with real number entries, A plus A transpose is symmetric and A minus A transpose will always be a skew symmetric matrix. Let us prove this. Suppose you take a matrix B which is A plus A transpose. Then what is B transpose? A plus A transpose whole transpose. Now you know that A plus B transpose is nothing but A transpose plus B transpose. So the first element transpose is A transpose. Second element is A transpose transpose. But you know that is equal to A. So basically you have got B transpose as again A plus A transpose, means B. If B transpose is B, then B has to be a symmetric matrix. But what was B? B was A plus A transpose. So first part we have proved that A plus A transpose is a symmetric matrix. Now take another matrix C which is A minus A transpose. Same way, take the transpose of C, simplify it. What will you get? A transpose minus A transpose transpose, means A transpose minus A. Can you write it as minus of A minus A transpose? Yes. So that is nothing but minus C. So we have obtained C transpose as minus C. So C is a skew symmetric matrix. But what was C? A minus A transpose. So we have proved that A minus A transpose is a skew symmetric matrix. Theorem 2. Any square matrix can be represented as the sum of a symmetric and skew symmetric matrix. This you can be asked in objective type of questions also. You can use this result. That means, what does it say? Suppose if A is a square matrix, then we can express A in the form of the sum of some symmetric and some skew symmetric matrix. Now which will they be? Let us see. Suppose you have a matrix A, then can you write A as half of A plus A transpose plus half of A minus A transpose? Yes, because A transpose will get cancelled. Half A plus half A is A. So basically from the first theorem, first of all you are having A as a sum of two matrices. So from the first theorem just now which we have seen, we know that A plus A transpose is symmetric always and A minus A transpose is always skew symmetric. So for our given matrix A from the equation 1, we know that first thing is we use the result K into A transpose is K into A transpose. So from equation 1, the first term is half into A plus A transpose. So what we have done is we have multiplied a scalar half by A plus A transpose. So obviously it is a symmetric matrix by the first theorem, correct? Because by the first theorem, if A plus A transpose is symmetric, half into A plus A transpose will also be symmetric. Similarly, by the first theorem, if A minus A transpose is skew symmetric, Obviously half into A minus A transpose is also skew symmetric. So we have shown that any matrix A, square matrix A, can be expressed as a sum of symmetric and skew symmetric matrix. So suppose you are given an example that express the matrix A as a sum of some symmetric and skew symmetric matrix. What you have to do is first find A plus A transpose multiplied by half. So that will be a symmetric matrix. Then find A minus A transpose multiplied by half. That will be a skew symmetric matrix. And always you can verify A is the sum of these two matrices. Next important theorem. You have to prove the uniqueness of inverse. Inverse of a square matrix, if it exists, will always be unique. Suppose you are having a matrix A which has elements of the type Aij. It is a square matrix of order n. Suppose that B and C are two inverses of A, but if we want to prove the result, we should be able to prove that they are the same because it should be unique. Now since B is the inverse of A, by definition of inverse, A into B is B into A, which is equal to the identity matrix I. Similarly, since C is the inverse of A, AC is equal to CA is equal to I. 1 and 2 from both of them. Suppose if I want to write B, first of all B I can write as B into the identity matrix I. Any matrix can be written as matrix into the identity matrix. Now what is I? I you can write as AC. Now you know that if you change the position of the bracket, it will not change. So B into AC is same as BA into C. But what is BA again? By first equation it is I, identity matrix. So I into C, but I into C is C. So basically we have shown by simple maths that B and C are same. That means we have proved that inverse of a square matrix, if it exists, is always unique. Now we know that the multiplication of matrices is not commutative. Addition is commutative, but multiplication might not be commutative. So now theorem 4 says that if A and B are invertible matrices, that means its inverse exists. Then A into B whole inverse is B inverse into A inverse. Remember, B inverse into A inverse is not the same as A inverse into B inverse. So we need to prove that AB whole inverse is equal to B inverse into A inverse. By definition of inverse of a matrix, what do we have? Any matrix into its inverse is the identity matrix. So AB into AB whole inverse is I. Correct? Now pre-multiply both the side by A inverse. So what do we get? You know that you can change the position of the bracket. So A inverse into A into B into AB whole inverse is equal to A inverse, but A inverse into A is I always. So IB, but IB is again B. So what we have obtained is B into AB inverse is equal to A inverse. Now again pre-multiply by B inverse on both the side. Correct? So it is B inverse into AB inverse is equal to B inverse A inverse. B inverse into B is I. So what you have obtained is AB whole inverse is B inverse into A inverse. Now we start with the different examples. Find the values of x, y and z from the given equation. That means we are given two matrices which are equal. You know, if the matrices are equal, obviously they should be of the same order, and they are of the order 2 cross 2 over here. And each of the elements of the corresponding matrices are equal. So you just have to compare the terms. It is first term, A11 term, x plus y is equal to 6. Then the first row, second term, what do you get? 2 and 2, they are same, already given. Second row, first column, 5 plus z, that should be equal to 5, and xy is equal to 8. So first thing is the 5 plus z is equal to 5, that means z is 0. So that is simple. Now just solve the other two equations. X is equal to 6 minus y, correct? So now another equation is x into y is 8. In that put x as 6 minus y, simplify it. You will get a quadratic equation. You know how to get the roots of a quadratic equation. So if you solve it, you get y as 4 or y as 2. If y is 4, x is 6 minus y, means 6 minus 4, which is 2. And if y is 2, x is 4. So there are two possible solutions for this. First one is x2, y4, z0, and second one is x4, y2 and z is equal to 0. Example 2. The number of all possible matrices of order 3 cross 3 with each entry 0 or 1 is, you have to find how many possible matrices are there of order 3 cross 3, and each of the entry can either be 0 or 1. Now this we are going to use the basic concept of permutation. We know that number of ways in which n objects can be arranged in r places without repetition is n factorial. With repetition is n raised to r. So here obviously only two elements which can be repeated any number of times. If there are two elements and number of places in 3 cross 3, how many elements? 9 elements. So the possible arrangement will be n raised to r or 2 raised to 9, which is 512. Remember, instead of 0 or 1, you can be given any two other elements also. Example 3, it is a conceptual question. Suppose you are having 5 different matrices of the given order. Then the first case is you want the restriction on n, k and p so that py plus wy will be defined. Now see, first term is p into y. That means matrix p into matrix y. When can you multiply two matrices? When the column of the first matrix and the row of the second matrix will be the same. I mean the number of elements in the column of the first matrix, number of columns of the first matrix and number of rows of the second matrix will be the same. So now you know that P is of the order P cross K. Y is of the order 3 cross K. That means your K should be equal to 3. First thing is your K should be equal to 3. Correct? And for the second term, which is W into Y. W into Y. W is of order n cross 3 and Y is of the order 3 cross K. So W into Y will be of the order n cross K. So first thing is you are having K is equal to 3 and your W into Y is of order n cross K. Now if you want to add two matrices, you know again it should be having the same number of, that means the first term and the second term should be having the same number of rows and columns. So Py plus Wy will be defined if P cross K is same as n cross K, because Py is of order P cross K and Wy is of the order n cross K. That means your P should be equal to n. So there are two conditions. First condition here is your K should be equal to 3. Second condition is P should be equal to n. Only in that case Py plus Wy will be defined. Second condition, if n is equal to P, then the order of matrix 7 into x minus 5 into z will be what? Now 7 into x is of order 2 cross n. So obviously you are multiplying a scalar. So 7 into x will also be of order 2 cross n. Same way, since z is of order 2 cross p, 5 into z will also be of order 2 cross p. Again you are subtracting two matrices, they should be having the same order. That means your 2 cross n and 2 cross p should be same. So obviously n should be equal to p. So the condition for 7x minus 5z, that means the order of 7x minus 5z will be of 2 cross n, or since n and p are same, 2 cross p. Example 4. If matrix A has elements 1, 0, 2, 0, 2, 1, 2, 0, 3, you have to prove the given equation. A cube minus 6a square plus 7a plus 2 into I is equal to 0. So we will do step by step multiplication and the other algebraic operations. Be very careful with the calculations. Matrix A is given. First thing is you find a square, means a into a. Just write the two matrices. Now how do we multiply two matrices? As I told you, suppose you want the first element of a square, that means a1 1. So you take the first row of the first matrix and the first column of the second matrix. So 1 into 1 plus 0 into 0 plus 2 into 2. That will be the first element. Now you want the element A12, means the first row, second column element of A square. So what you have to do is you have to take the first row of A, means first row of the first matrix, and the second column of the second matrix. Correct? So it is 1 into 0 plus 0 into 2 plus 2 into 0. Next, you want the A1/3 element of A square. That means first row, third column. So you have to take the first row of the first matrix and the third column of the second matrix. So 1 into 2 plus 0 into 1 plus 2 into 3. This is how you find all the elements when you multiply two matrices. Be careful in the calculations. So you get A square over here, 508, 2, 4, 5, 8, 0, 13. Now we want A cube. A cube means A square into A. So whatever A square you have obtained, you write that matrix and then you write the matrix A. Again same thing, multiply it. So suppose if I am taking, for example, if I want the element in the second row first column, that means A21 element of A cube. So what I have is the second row of the first matrix into the first column of the second matrix. That means I will have over here second row first column means 2 into 1 plus 4 into 0 plus 5 into 2. So that is equal to 12. Similarly other elements. Now just write the left hand side. It is A cube, means you write the matrix A cube minus 6 into A square. Remember, if any scalar is multiplied by a matrix, you have to multiply that scalar by each and every element. So you multiply 6 by every element of A square. So 6 into 5, 36 into 0, 0, 6 into 8, 48 and so on. Plus 7 into A similarly, plus 2 into I. 2 into the identity matrix, diagonal elements will be 1. So it will be the matrix 2, 0, 0, 0, 2, 0, 0, 0, 2. Now just do the simple calculation. For example, the first element 21 minus 30 plus 7 plus 2. What is that? 0. If you do all the elements, you will be getting the matrix which is the 0 matrix. All the elements are 0. Hence, we have proved the equation. Example 5. If f of x, that means you are having matrix which is basically written in the form of a function. Cos x minus sin x 0, sin x cos x 0, 0, 0, 1. This is the matrix for f of x. You have to show that f of x into f of y is equal to f of x plus y in this case. So again you start with the left hand side. Now see, f of x is given over here. What will be f of y? It will be cos y minus sin y 0. Sin y cos y 0. 0, 0, 1. So just multiply the terms. Again I am telling you, to get the multiplication of two matrices, take the row from the first matrix and the column for the second matrix. Correct? So if you do the calculations, you will be getting the matrix f of x into f of y as shown over here. So first term is cos x cos y minus sin x sin y. But you know that is the formula for cos of x plus y. Second term, take out minus common. First row, second column element. That means you take out minus common, you will get cos x sin y plus sin x cos y. That is again sin of x plus y. So second term is minus of sin x plus y. Similarly, all other terms, if you simplify, you will get this. So what is this basically? This is our function f. But instead of x, the element over here is x plus y. Correct? So what we have shown is f of x into f of y in this example is giving us f of x plus y, which is equal to the right hand side. Now you have some real life application examples of matrices. They will be interesting. Example 6. A trust fund has rupees 30,000 that must be invested in two different types of bonds. The first bond pays 5% interest per year. Second one pays 7%. Using matrix multiplication, determine how to divide the fund of rupees 30,000 among the two types of bonds, so that the annual total interest in the first case you are obtaining is rupees 1800 and in the second case rupees 2000. Now first thing is what is given to us is total amount we have is 30,000 that we have to invest in two types of bonds. So suppose in the first bond we are investing X. So in the second bond the investment would be 30,000 minus X. So see we have to use matrices. So first we will form all the type of matrices over here. First one is the investment matrix, that is X and 30,000 minus X for the two bonds. Second is the interest matrix for both the bonds. The interest matrix, the first bond gives 5% means 0.05 interest and second one gives 7% means 0.07. Now in the first case what you want is the annual interest matrix. You want the annual interest to be 1800 in the first case and in the second case you want the annual interest to be 2000. Now see I have written the order for each of them because when we want to multiply again we have to check the order for the matrix. Investment matrix 1 row 2 columns, so 1 cross 2. Interest matrix 2 rows 1 column, so 2 by 1 matrix. Annual interest matrix will be just having one element. So now in the first case when we want the annual interest to be 1800, how to get the interest? Investment into the interest will give you the total annual interest, correct? And investment into the rate of interest will give you the total annual interest. So you are multiplying the first matrix, which is the investment matrix, into the rate of interest matrix. See, check over here, 1 cross 2 and 2 cross 1. Yes, you can multiply because the columns of the first one is equal to the number of rows for the second one. Now when you multiply two matrices which are of the order 1 cross 2, 2 cross 1, you should be getting a matrix of the order 1 cross 1. And that should be equal to, in our first case it is 1800. Multiplication is simple. You take the row from the first one, you take the column from the second one. So I have given X into 0.05 plus 30,000 minus X into 0.07, which is 2100 minus 0.02x. It is a 1 cross 1 matrix. This should be equal to 1800 in the first case. When you simplify it, you will get the value of x as 15,000. Means if the annual interest is rupees 1,800, then the investment in the first bond is 15,000. So in the second bond, it will be 30,000 minus 15,000, which is again 15,000. Second case you want your annual interest to be rupees 2000. So repeat the same procedure, but over here the right hand side is 2000. So you simplify the equation, same equation, 2100 minus 0.02x. Here it is equal to 2000, gives you x equal to 5000. So in the second scenario, the investment in the first bond is rupees 5000. So in the second bond, it will be 30,000 minus 5000, which is 25,000. Next example. Find the element x if the first matrix is x minus 5 minus 1 into the second matrix into the third matrix is equal to 0. Now see, first matrix 1 row 3 columns, 1 cross 3, second matrix of the order 3 cross 3, third matrix of the order 3 cross 1. Correct? So first what you do is first you take the first two, multiply the first two. So when you multiply 1 cross 3 order matrix with 3 cross 3 matrix, what do you get? 1 cross 3 matrix, means just 1 row but 3 columns. So now row from the first one and second from the column from the second one. So x into 1 plus minus 5 into 0 plus minus 1 into 2. So that is x minus 2. Second element, x into 0 plus minus 5 into 2 plus minus 1 into 0. So that is minus 10. Third element, x into 2 plus minus 5 into 1 plus minus 1 into 3. Correct? So that is 2x minus 8. Now we multiply this by the third matrix. Correct? So what do you get? Again, you are having 1 cross 3 multiplied by 3 cross 1. So the matrix will be of the form 1 cross 1. That means only one element. So you will get an equation. You just simplify this equation. It is a quadratic equation, x square minus 48, which should be equal to 0 given. So x square should be equal to 48. So x is equal to root of 48. But 48 you can write it as 16 into 3. So it is plus or minus 4 root 3. Example 8. If matrix A is given by elements cos alpha minus sin alpha, cos alpha, and it is also given that A plus A transpose is equal to identity matrix, and you have to find the value of alpha. So now first thing is A transpose. How do you get it? Interchanging the rows and columns. First column cos alpha sin alpha will become first row, and second column minus sin alpha cos alpha will become the second column. Second column will become the second row. So now A plus A transpose means just add the corresponding elements. So what do you get? Cos alpha plus cos alpha minus sin alpha plus sin alpha minus sin alpha, and cos alpha plus cos alpha. So now this is given to be equal to our identity matrix. So this should be equal to 1 0 0 1. So now we equate the corresponding terms. 2 cos alpha is 1, cos alpha is half. When cos is half, when the angle is pi by 3. So alpha should be equal to pi by 3. In the next example, you have to prove this result. If A has elements cos theta sin theta minus sin theta cos theta, you have to prove A raised to n will have the elements of the form cos of n theta, sin of n theta, minus sin of n theta, cos of n theta for any natural number n. Always remember, in maths, if you want to prove any result for n, that means for any natural number n, principle of mathematical induction is very useful. What is the principle of mathematical induction? I am just repeating. You just have to prove the given result. First you have to prove the given result for n is equal to 1. Then you have to assume that the given result is true for n is equal to k, for some k. Using this assumption, just show that it is true for k plus 1 also. So if you are able to do that, the result is true for any n. First step, you have to show that the result is true for n is equal to 1. This is but obvious because given matrix is A and A raised to n, in that if you put n as 1, you will be just getting A. So A raised to 1 is A. The result is true for n is equal to 1. Now important thing, assume that the result is true for n is equal to k. If the result is true for n is equal to some k, then your A raised to k should be equal to cos k theta sin k theta minus sin of k theta cos of k theta. Using this assumption, means this we have assumed to be true. Using this assumption, let us try to prove it is true for k plus 1 also. So now what is A raised to k plus 1? You can write it as A into A raised to k. So first write your matrix A, then write your matrix A raised to k. Multiply the given terms. Now you know how to multiply two matrices, the row from the first one and the column from the second one. So you get the given matrix. Now just simplify this using the sum of angle formula. Cos theta cos k theta minus sin theta sin k theta. This is nothing but cos of theta plus k theta. Similarly, the second term is sin of theta plus k theta. The third term, take out minus sign common. So it is sin of theta plus k theta again. And in the last term, it is cos theta cos k theta minus sin theta sin k theta. So that is cos of theta plus k theta. So now what you have shown is over here. Now theta plus k theta, take out theta common, it is theta into k plus 1. So this is equal to cos of k plus 1 of theta sin of k plus 1 of theta minus of sin of k plus 1 of theta cos of k plus 1 of theta. This is nothing but for the result is true for k plus 1. So what is the important thing we have done? We had assumed that the result is true for n is equal to k. Using this assumption, we have shown that it is also true for n is equal to k plus 1. Correct? So by principle of mathematical induction, the result is true for any natural number n. Example 10. A manufacturer produces 3 products X, Y and Z which he sells in 2 markets, and the annual sales are given for each market with the given products. In the first case, if the unit sale prices of X, Y and Z, the 3 products are respectively rupees 2.5, 1.5 and 1, then you have to find the total revenue in each of the market with the help of matrix algebra. So first thing is just list the given matrices. So first matrix, it is markets with the products. It is a 2 cross 3 matrix. The matrix for the unit selling price for the 3 different products is 3 cross 1 matrix. So now for getting the total revenue, you just have to multiply the number of units of the product into the unit selling price. Correct? So now you can, since the first matrix is of order 2 cross 3, second of 3 cross 1, when you multiply, you get a matrix of the order 2 cross 1. Just multiply the matrices. The first element is 46,000 and the second is 53,000. These two are for the two different markets, market 1 and market 2. So what we have obtained is revenue for the market 1 is rupees 46,000 and the revenue for the market 2 is rupees 53,000. In the second part of the question, it is given if the unit cost of the above three commodities X, Y and Z is 2, 1 and 0.5 respectively, you have to find the gross profit. First thing is, you know, profit is equal to selling price minus cost price. For the cost price, the matrix is for the three different commodities X, Y and Z. The unit cost is 2, 1 and 0.5. So profit per unit will be the selling price minus cost price. You have to multiply the selling price matrix, you have to subtract the cost price matrix from the selling price matrix. So selling price matrix we already have 2.5, 1.5 and 1 minus the cost price matrix which is 2, 1 and 0.5. So you get 0.5, 0.5, 0.5. What is the gross profit? The sales into profit per unit. So the sales already we have given the matrix for the two markets. The sales is given annual sale, correct, into the profit. So for the first, when you multiply these two matrices, 2 cross 3, 3 cross 1 means you will get a matrix of the order 2 cross 1. 2 rows, 1 column, 2 rows for each of the markets. So it is 10,000 into 0.5 plus 2,000 into 0.5 plus 18,000 into 0.5 which is 15,000. Similarly, second element is 17,000. So the gross profit for the first market is 15,000 and for the second market is 17,000. So if you want the total gross profit including both the markets, it is 17 plus 15, 32,000. Next example. Find the matrix X so that matrix X, remember X is a matrix, matrix X into the given other matrix is equal to the matrix minus 7, minus 8, minus 9, 2, 4, 6. Means in short, you have to find a matrix X such that when X is multiplied by another matrix which is of order 2 cross 3, you get a resultant matrix which is of the order also 2 cross 3. Now see, when you want a resultant matrix of order 2 cross 3 and that is a multiplication of two matrices, then the first matrix should be having 2 rows, correct? And that first matrix is multiplied by another matrix which is having 2 cross 3 means 2 rows and 3 columns. Then the first matrix should also be having 2 columns. In short, you are multiplying X which is of order 2 cross 2 into another matrix which is of order 2 cross 3. So the resultant matrix is of order 2 cross 3. Okay, so first thing you have to decide that. So now first we have decided that X should be of order 2 cross 2. So suppose if X has elements P, Q, R and S. So you are having P, Q, R as this matrix multiplied by 1, 2, 3, 4, 5, 6 another matrix and the resultant matrix is also given. Now you know multiplication of two matrices, row from the first one, column from the second one. So P into 1 plus Q into 4. This will be the first term. Then first row second column term will be P into 2 plus Q into 5. So 2P plus 5Q and so on. Now compare when two matrices are equal, the elements, corresponding elements are equal. So just equate the corresponding elements. You will be getting these 6 equations. Now you are having 6 equations, 4 unknowns. You can use any of the equations and get the value of the 4 unknowns. So suppose if I solve P plus 4Q is equal to minus 7 and 3P plus 6Q is minus 9 means P plus 2Q is minus 3. Just solve them, you will get P as 1, Q as minus 2. Similarly, if you solve the equation R plus 4S is 2 and 3R plus 6X is 6, then you get the value for R and S. R is 2, S is 0. So in short, our matrix which has elements P, Q, R, S, it will be 1, minus 2, 2, 0. So thus we have obtained our matrix X. Now some objective type of questions. Answers are already given. Suppose you are having a matrix A which has elements alpha, beta, gamma and minus alpha such that A square means A into A is equal to identity matrix I, then you have which of the following equations would be true? Just multiply A with A. So you will be getting that the equation will be 1 minus alpha square minus beta into gamma is equal to 0. This equation would be true. So option C is correct. Second one, if the matrix A is both symmetric and skew symmetric, then A should be a diagonal matrix, zero matrix, square matrix, or none of this. The answer is only it is possible when A is a zero matrix. If A is a zero matrix, then only it can be both symmetric and skew symmetric, because when A and minus A are same, when is that possible? Only when it is a zero matrix. Third case, if A is a square matrix such that A square is equal to A, then I plus A whole cube minus 7 into A is equal to what? The answer is C. It is very simple. Just simplify this equation, and wherever there is A square, you can put A. So you will be getting the option C as correct. That means it should be equal to the identity matrix I. See, matrices from class 12 is a easy topic, but you need to be careful with the calculations. Do like and share the video and subscribe to the channel for the other topics of class 12 maths.